Hello students, I welcome all of you to the concluding session of this human eye and the colorful world. In the last 3 classes, you have enjoyed Hello. Hi, good morning to everybody, my dear children. This is the final and concluding session of this human eye and colorful world lesson. In the last 3 classes, I tried my best to convince you to teach several points related to this concerned lesson. You have participated very well, and I hope you had completed the task which I had given earlier in the form of the homework and as well as the activity. Okay, let us come to the present lesson. Before we go to this lesson, let us recall once again what were the teaching points which we have already learnt in the previous period. These were the points which you have learnt already in the previous period. This period you are supposed to learn the scattering of the light, the Tyndall effect, why the color of the sky always appears blue, then the color of the sun during sunrise as well as the sunset, then finally few problems related to this lesson. Okay, let us go to the lesson now. Scattering of the light. What is the meaning of scattering of the light? Scattering means nothing but spreading of the light. Whenever the light passes through the atmosphere, it scatters. This phenomenon is called as the scattering of light. This is general definition of the scattering of the light. In detail, I am going to teach you later. Before that, you know the sunlight is composed of totally 7 colors: violet, indigo, blue, green, yellow, orange as well as the red. This is the wavelength of all these colors. You know what is the meaning of the wavelength? The light itself is called as a wave. The distance between 2 consecutive crests or trubs is called as the wavelength. If you see the chart of the wavelength, the violet wavelength is very less, like 400 nanometer. Nanometer is a very special and small unit used to measure the wavelength of very shorter wavelengths. So, like using meter and centimeter, we cannot measure the wavelength here, because the wavelength is very less. So, therefore, we make use of the nanometer. Red wavelength is normally more. So, it has the larger wavelength. Even this also comes to our help in the next coming facts which we are going to discuss. Normally, we know atmosphere is a thin blanket of air which surrounds the earth. See, atmosphere is composed of small particles as well as the large particles. The small particles means it is composed of the air molecules such as nitrogen, oxygen and several traces of the gases. The larger particles means nothing but the water droplets, water vapor, dust and smoke which is present in the atmosphere is grouped as the large particles. Small particles as well as the large particles constitute to make a beautiful atmosphere. See, whenever the light is made to pass through the large particles are going to scatter light of longer wavelength. I told already violet is having least wavelength and red is having longer wavelength. Anyhow, the larger particles will scatter the light of the longer wavelength. Let us see how the scattering is going to occur. Now, the light from the sun is entering into our earth atmosphere. Before it enters, it travels in the vacuum, that is why it will not bend anywhere. As soon as it approaches the larger particles of our air, it is going to scatter like this. The longer wavelength color is scattered In addition to that, even other colors are also scattered. See, you could see the white clouds. Why the clouds is having white color? Any reason behind it? You might have seen the clouds everywhere. Why? What is the reason for that? See, the clouds basically it is not a solid. The clouds are composed of the water droplets. As per the classification which I have told earlier, the larger particles are nothing but water droplets. These larger water droplets constitutes the cloud, and these particles they are going to scatter the light, and all the colors of the light are scattered equally. All the colors of the light are scattered equally. That is why the cloud appears to be white in color. Comes to the next concept, very small particles. Here small means even you can say very fine particles. Already you know which are the small particles or which are the fine particles. As soon as they passes through the earth atmosphere, the small particles they scatter mainly blue light. I mean they scatter mainly the color of the light which have less wavelength. In this way, the larger particles as well as the smaller particles they are going to scatter the white light. You could see this is called as the canopy. Like in the dense forest, the sunlight is going to enter like this and it is going to scatter. Why it is going to scatter? Because due to the water droplets which are present in the dense forest. So, in this way the scattering of the light is mainly responsible, and it mainly depends upon the size of the particles. If it is large, the longer wavelength is going to be scattered effectively. If it is small, the smaller wavelength is going to, the range of the smaller wavelength is going to scatter effectively. Okay. Let us proceed further. True solution. What is the meaning of true solution? If you take sugar and water and if you mix it, they are going to dissolve completely. Before mixing, we can say this is sugar and this is water. When they get completely mixed, it becomes a homogeneous mixture. In this homogeneous mixture, the solute and the solvent they cannot be retraced again, but they combine together to form a solution. This is true solution. Next to suspension. As the name itself indicates, something is going to be suspended without dissolving completely. You take the clay or chalk powder and mix it with water, it is going to dissolve, but partially it is going to dissolve by leaving some components to suspend on the upper strata. Hence, this kind of solution is called as the suspension. Next to colloidal solution. The property of the colloidal solution is in between the solution as well as the suspension. Mainly, we have milk as a very good illustration for this colloidal solution. Now, let me conduct one experiment regarding all these three solutions. Take water, take sugar, mix it. Now, what is going to happen? They are going to mix completely. Now, allow the light to pass through it. Can you able to see the path of the light? No, you cannot see the path of the light, because the lighter particles of this true solution are not able to scatter the light, because they are very small particles, they cannot scatter the light. So, therefore, the path of the light which is passing through this solution is not visible clearly. Overall, we can say that the molecules of the true solution they do not scatter the white light. You take the second. Now, I am going to leave the light through the suspension. You could see the path of the light so effectively. This indicates that the larger particles which are floating, they can scatter the white light so effectively, so that you can see the path of the light. Now, I am going to leave the light through the milk. I am going to ask you the question, what is your observation, what is your conclusion? Definitely if you leave the light, can you see the path of the light? Some category of the students they told, sir, we cannot see. Yes, you are right. And some category of the students they told that, sir, we can see the path of the light. Even you are also true. But actually what is the case means, in the colloidal solution, the scattering of the light is very difficult to observe by using our naked eyes. We must make use of the microscope to see the path of the light. That too, very small particles of this colloidal solution, they may scatter the light, and that can be seen through the microscope effectively. So, therefore, overall one thing I learnt very well by conducting the experiment through these solutions is, when the light is made to pass through the colloidal solution, it is going to scatter. This experiment was conducted by famous scientist Tyndall, hence it is called as Tyndall effect. He had given a beautiful explanation for this. The phenomenon of scattering of the light by the colloidal particles is called as the Tyndall effect. After understanding the Tyndall effect effectively, you can just correlate it with the scattering of the light through the dense forest also. Even that is also nothing but Tyndall effect. And you can give many examples for the colloidal solutions also. Through all these colloidal solutions, if you leave the light, it is going to scatter. Okay, children, let us go through another interesting factor. Why is the color of the clear sky is blue? Since from birth till now, every day we are going to watch the blue color sky and we are going to enjoy so nicely. But any one of you have questioned why the color of the sky is blue? Certainly we are observing it every day, but why it is going to be blue? Like this, you have to think critically to get the answers in science. Otherwise, simply if you receive as it is, no, it is nature, I say, the color itself is blue, I say, why I should bother, it is appearing blue. You should not come to such conclusion, you have to think. There is a perfect scientific explanation for the color of the blue sky, that I am going to explain it now. See, that is sun. The sunlight is entering. First it travels in the vacuum. So, therefore, it do not gets deviated or it do not scatter. Now, it is going to enter through our earth atmosphere. The light particles of the earth atmosphere, they scatter blue light effectively than the red light. Very effectively the blue light is scattered. The blue light is more scattered compared to all other colors. That is why that blue light comes to our eyes and we can see the color of the sky as blue. What a nice explanation. See, this is the blue color sky which you have noticed in the nature. Next, even if you go to the coastal regions, especially the ocean water is also blue. Why that is also blue? As usually the sunlight enters through the water, the molecules of the water, they scatter blue light effectively than any other light. That is why the ocean water also appears to be blue. The color of the sky as well as the ocean light appears to be blue because of the scattering of the light through smaller particles. What a nice explanation, what a nice scientific phenomenon which we have seen, and so far we enjoyed the beauty of the nature, especially blue sky as well as the blue colored water in the ocean, but we had no idea about the blue color. Now you understood it. I think you got very nice enjoyment. Okay, with the same enjoyment, let us continue further, my dear children. Then, color of the sun at sunrise and sunset. The sunrise and sunset, normally it appears to be red color. Why the color of the sun is red during sunrise and at the time of the sunset? You have seen sunset and sunrise from the beginning till now, and you enjoy the sunrise and sunset. Sometimes if you go to the coastal regions, especially in the ocean and all, if you are observing the sunrise or sunset, we feel sun is going to fall into the water at the time of sunset, and we feel the sun is raised from the water upwards. Yes, it is true. It is the true natural phenomena, because it is a colorful word which we enjoyed very nicely, and we are going to enjoy it forever. Now, let us try to understand why the color of the sunrise and sunset is always red. See, you could see this slide effectively. See, at noon the sun is naturally nearer to us, but at the time of sunrise and sunset the sun is little bit far away. The distance factor is very important. At noon the distance is less, but at sunrise and sunset the distance is more. Let us see what happens at noon. At noon, the particles of the atmosphere, they scatter the sunlight effectively. Almost all the colors, more or less, they are scattered. That is why it appears to be white in color at noon. But at the time of the sunrise, let us see what is going to happen, what a nice spectacular event is going to be happen. At the time of sunrise, the sun is exactly at the horizon. The sunlight travels longer distance to reach us. The large particles of the air at the horizon, they scatter sunlight least. I mean, the red color of the red color is going to be scattered least compared to all other colors. The blue colored light almost scattered away. Due to the longer wavelength, the red color is going to scatter least, and that will reach us effectively. That is why the sunrise is going to appear red at the time of the sunrise. Even at the time of the sunset also, the larger particles which are present near the horizon, they scatter the red light least due to its longer wavelength, and that reaches our eye. Hence, the sun appears to be red in color. This is all. The color of the sunrise, sunset sun is mainly red color. Because of the longer wavelength, red will reach us effectively compared to smaller wavelength like blue color and some other colors. So, this beautiful phenomenon we understood so effectively. Okay, let us proceed further, and now we can see the beautiful sunrise and sunset, and we enjoyed it very nicely. Next, why is danger lights are red in color? Have you seen danger light? Yes, you have seen, especially when we are traveling on the road near the traffic signals. We could see the red light. Red light indicates what? Yes, it indicates stop, whatever it may be. Why it indicates stop? Some other vehicles are moving, you stop. Otherwise, if you go, you are going to clash, and you mean danger. So, therefore, danger light is always red. But why the danger light is always made by red color? Any scientific reason is there behind it? Definitely, there is a scientific reason behind it. See here, children, you can see red light, green light and blue light. The blue light scatters, it scatters most, and its wavelength is very less. So, it scatters completely. and compared to blue light, the wavelength of the green is little bit better. It scatters and it scatters longer distances. Next, see the red color, the larger wavelength. Due to the larger wavelength, it scattered least and then it reaches our eye. So, compared to blue and the green color, the red light, due to its longer wavelength, it reaches our eyes effectively, especially due to the dust particles which are accumulated in the atmosphere. We may be not able to see the red color effectively, other colors effectively other than the red, and even when the fog or some other things are there in the nature, even at that time also we can see the red color effectively. Through the dust particles and because of the fog, the red light is going to be visible effectively than other colors. So, due to this reason, due to the longer wavelength of the red light is considered as the best light for the danger light. So, that is why the danger light is mostly made by red in color. I hope you understood it effectively, children. Okay, children, till now you could be able to understand many natural colorful phenomena which occur in our surroundings. Till now our contents oriented colorful world facts were really analyzed effectively. Now, let us go to work out a few problems in this human eye and colorful world. You see, this is the first problem. A person needs a lens of power minus 5.5 diopters. See, diopters is the unit of the power and meter is the unit of the focal length. See here, he is going to use minus 5.5 diopters length. What is the focal length? And he is going to use plus 1.5 diopter lens. What is the focal length? Our intention is to find out the just focal length. We have a formula. Focal length is equal to 1 by power, f is equal to 1 by p, 1 by you substitute minus 5.5 because the power is given, and if you go through the fundamental operations, if you apply all the fundamental operations of the mathematics, if you apply all the fundamental operations of the mathematics and later if you simplify, you are going to get the value of the focal length is minus 0.18 meter. And in the second case also the same formula, f is equal to 1 by p, 1 by 1.5. When it is subjected to the further calculation, we get the focal length of the lens required for the correction of that particular vision will be, the correction of particular defect will be 0.667 meter. Let us go to second problem. The far point of a myopic person is 80 centimeter in front of the eye. What is the nature and power of the lens required to correct the problem? First of all, you write down what is given. U is equal to infinity, that is minus infinity, because object distance is always negative, minus infinity. V is equal to minus 80 and we are supposed to find out the focal length, f is equal to question mark. We know lens formula, 1 by f is equal to 1 by v minus 1 by u. Now, please apply the object distance as well as the image distance values effectively, and finally, you can get 1 by f is equal to minus 1 by 80 and f is equal to minus 80 centimeter. Convert it into meter, minus 0.8 meter is the perfect answer. That means, we found out the focal length effectively by using the values for u and v. Now, come to the next concept. We are supposed to find out the power. Power is equal to 1 by focal length. Focal length is equal to 1 by p. Similarly, power is equal to 1 by f is equal to 1 by minus 0.8. If you just divide, you will get power is equal to minus 1.25 diopters. So, in this case, we must make use of the concave lens. Okay, let us move to the third problem. In this problem, just we are supposed to make a diagram. You need not solve the problem, you are supposed to make a diagram. Especially for hypermetropia, for long sightedness, we know how to draw the ray diagram. The same ray diagram we are supposed to draw even here also. See, the eyeball size is less, convex lens. For the correction, we are going to make use of the convex lens. See, this is called as the near point of the correct eye, near point of the correct eye which have no defect. But as per this problem, so they are going to say the near point extends up to 1 meter, that means 100 centimeter. So, in this way this problem can be solved by drawing the ray diagram effectively. Okay children, till now the facts which you have accumulated in the mind, it should come out in the form of the answers for my questions. I hope all the students are very effectively and with all interest you are going to answer the questions. Okay, let us start the first question. The color of the sun during sunrise. See, I had given colors. Anybody is there among you who have not seen the sunrise? Most of you have seen, not most of you, everybody has seen the sunrise. What is its color, my dear children? Sure, 100% that is the color. The color of the sky appears from the moon. So, once again I am going to say, see, the color of the sky is blue only on the earth. Suppose if you get a chance to go for moon, the moon is away from us, like almost 4 lakhs kilometer away from us. If you go to the moon, what is the color of the sky? Is it red? Is it blue? Is it black or anything? Definitely you have to realize one fact very clearly. If you go to the moon, above moon there is no atmosphere. When there is no atmosphere, the light will never scatter. If the light does not scatter, definitely the sky does not appear blue. Then what is the color of the sky if there is no atmosphere? Definitely it is black color. The color of the spectrum of the light which has least wavelength. Please recall the spectrum of the light from V to red, Vib Gayar, which is having least wavelength and which is having larger wavelength, you know very well. So, okay, that is your good answer, that is violet. The color of the danger light, just now I told danger light. So, definitely before I stop asking the question, already you have answered it, that is danger light is red color. The color of spectrum of light which has longer wavelength, sunrise, sunset, you recall and you please give the answer. Your answer is definitely this one only. Okay children? Okay, till now even in the recapitulation also your participation was very amazing. Now, after the conclusion of this lesson, I am going to give mind map. Mind map is, it is nothing but giving the entire lesson in the points wise. By seeing those points, you could be able to narrate entire fact about that particular concept. So, therefore, simply by reading or simply by writing, you cannot understand anything effectively. You sit, you read, you write, lastly you sit at a lone place and try to recall once again by using this mind map. The human eye and the colorful world. First, let us take human eye. Yes, importance of the eye. Next, eyeball. As soon as I say the eyeball, already you started saying, sir, I know, sir, what are the things which are present in the eyeball? Okay, these are the things present in the eyeball. Sclera, choroid, cornea, iris, pupil, lens, ciliary muscles, retina. Okay, suppose I ask what is retina? Definitely you are going to say, sir, retina is nothing but the screen, sir, which is composed of cones and rods, sir. The cones and rods converts this one into optics, electric signals, sir. These electric signals are going to pass through the brain through the optic nerve, sir. Like that, by seeing the point, you are going to say entire history of that concept, In that way, the mind map is very much useful. Next, aqueous humor and vitreous humor are the only two liquid mediums which are present in the eyeball. Next, eye defects. As soon as I say eye defects, already you started saying these are the 4 eye defects. Yes, myopia, hypermetropia, presbyopia, cataract. And myopia, what is myopia? You know very well. What is the effect? You know very well. What is the reason? You know very well. And what is the remedy? You just recall by seeing the mind map again and again. So, in that way the mind map serves as a best tool for you to recall the points effectively. Next, come to the colorful word. In the colorful word, first refraction. Refraction through the glass slab, refraction through the glass prism, and atmospheric refraction, then naturally twinkling of the stars, then finally advanced sunrise and delayed sunset. So, in order all these happenings are going to happen because of the refraction of the light. Next, dispersion. So, how the dispersion is going to happen? Through the glass prism, and what is the spectrum of the light? Then rainbow, how rainbow is going to happen? Like that, all the things you are going to recall. Then scattering of the light, just today we discussed, and Tyndall effect. Next, the color of the sky appears to be blue. The next, color of the sunset during sunrise and sunset. So, in this manner, by using the mind map, recall all the important points and try to elicit in the form of the important aspects. Okay, children, let me give some activity for you. So, I need not say observe the sunrise and sunset, you are going to observe and you are going to enjoy. If you go to coastal areas, you please enjoy the sunrise and sunset, and if possible you do some solutions, suspensions, colloidal particles, etc., and you pass the white light through it and try to observe the path of the light is possible to see or not. Lastly, I am going to give one assignment in the form of the 3 questions. The 3 questions are displayed on the screen. Without fail, please answer these questions. Okay, children, from the 4 periods, I tried to deliver few concepts regarding the human eye and the colorful world. You understood effectively, like how the blue color light is going to scatter and how the sky appears to be blue. Whatever the knowledge you have gained till now, it should scatter effectively and it should make the India to glow brightly. So, therefore, in the next coming days for your examinations and all, I always say best of luck, enjoy and read well and do well in the examination. All the best. Try to be an ideal student and try to come out with flying colors. Thanks for all the students who have cooperated with me from the past 1 month to have this colorful word and human eye lesson being taught as per the standards. Okay, thank you for one and all.